Something unusual has been happening in the Sahara Desert. In regions that were once completely dry, scientists are now detecting signs of water. Satellite images show patches of vegetation spreading across areas that used to be bare sand. In some places, seasonal lakes are forming after rainfall. And in certain regions, underground water is even beginning to reappear closer to the surface. This raises a surprising question. Is the Sahara Desert starting to turn green again? At first, that idea sounds unlikely. The Sahara is the largest hot desert on Earth, covering about 9 million square kilometers, roughly the size of the United States. It stretches across North Africa and includes some of the driest places on the planet. In many areas, rainfall is less than 25 millimeters per year, and some regions can go years without a single significant rain event. But despite these extreme conditions, the Sahara has not always been a desert. Thousands of years ago, much of this region looked completely different. During a period known as the African Humid Period, which lasted roughly from 11,000 to 5,000 years ago, the Sahara was covered with grasslands, rivers, and large lakes. Fossil evidence shows that animals like hippos, crocodiles, and even early human populations lived in areas that are now completely dry. So what changed? The main driver is Earth's orbital cycles. Small variations in the tilt and wobble of the planet affect how sunlight is distributed across different regions. Around 5,000 years ago, these shifts weakened the African monsoon system, reducing rainfall across North Africa. Over time, vegetation died off, soils dried out, and the Sahara transitioned into the desert we know today. But the climate system that created the Sahara is not fixed. And in recent decades, scientists have started to observe signs of change. Satellite data collected over the past 30 to 40 years shows that parts of the Sahara, especially along its southern edge in the Sahel region, have experienced increased rainfall. Some areas have seen precipitation rise by 10 to 30% compared to the severe drought periods of the 1970s and 1980s. This increase in rainfall has had visible effects. Vegetation has expanded across parts of the Sahel, with grasses and shrubs returning to areas that were previously barren. Researchers using satellite imagery have tracked a measurable greening trend across large portions of North Africa. In some cases, temporary lakes have formed in low-lying desert basins after heavy rains. These lakes may only last for weeks or months, but they indicate that water is becoming more available in regions that were once extremely dry. Another important factor is groundwater. Beneath the Sahara lies one of the largest underground water reserves in the world, known as the Nubian Sandstone Aquifer System. This aquifer contains vast amounts of fossil water that accumulated thousands of years ago when the region was much wetter. In certain areas, changes in rainfall and surface conditions may allow some of this groundwater to move closer to the surface. While this does not mean new water is being created, it can make existing water more accessible in localized regions. However, the situation is complex. Not all parts of the Sahara are becoming greener. While some areas show increased rainfall, others remain extremely dry, or are even experiencing higher temperatures and evaporation rates. Climate models suggest that warming global temperatures could intensify weather patterns, leading to both heavier rainfall events and longer dry periods. This means the Sahara is not simply turning green in a uniform way. Instead, it is becoming more variable. Some regions may see more vegetation and seasonal water, while others continue to face desert conditions. There is also evidence that human activity plays a role in these changes. Land management, agriculture, and reforestation efforts in parts of the Sahel have helped stabilize soils and support vegetation growth. Projects like the Great Green Wall Initiative aim to restore degraded land across Africa by planting trees and improving land use practices. These efforts can enhance the natural recovery of vegetation, especially when combined with increased rainfall. But scientists are careful about making long-term predictions. The African humid period developed over thousands of years due to gradual changes in Earth's orbit. The current changes observed in the Sahara are happening on much shorter timescales and are influenced by both natural climate variability and human-driven climate change. Some climate models suggest that parts of North Africa could experience increased rainfall in the future. Others predict expanding desert conditions due to rising temperatures. At this point, both trends are possible, depending on how global climate systems evolve. What is clear is that the Sahara is more dynamic than it may appear. Even the largest desert on Earth is not static. It responds to changes in climate, atmospheric circulation, and environmental conditions. In certain regions today, grasses are returning, water is briefly pooling on the surface, and ecosystems are beginning to reappear in places that were once completely barren. These changes are small compared to the vast size of the desert, but they are measurable, and they are real. The idea of a green Sahara may sound like something from the distant past, but the evidence shows that under the right conditions, the landscape can change again. For now, scientists continue to monitor rainfall patterns, vegetation growth, and underground water systems across North Africa. Because even in one of the driest places on Earth, the environment is still evolving.
The Sahara Desert looks like a golden sea from above. We see endless dunes, many blue and green oases, and a huge black spot that covers an area of 17,000 square miles. Wait, what? What is it? It's a pretty gigantic territory, but why have we rarely heard of it and never seen it in movies or documentaries? Perhaps it appeared recently. Oh no, this black spot is millions of years old. Let's go down and explore the area. This place looks flat from above, but it's extremely uneven. There are black hills, slopes, and strange, tall cones everywhere. Some of them reach a height of more than 330 feet. It's higher than the Statue of Liberty, and the highest peak reaches about 3,900 feet above sea level. All these formations seem to be burnt out. This whole area resembles a giant testing ground where something big was blown up, or where a large-scale fire burned. In some way, it's true. There was a fire here, not on the ground, but under it, and then it burst out. This entire territory is covered with molten lava. It came out of the ground and spread in different directions, burning everything in its path. Then, a new portion of lava came out and solidified on top of the previous layer. And so, with time, the lava formed a hill, a cone, and all the mountains located there. So, turns out this place is covered with small volcanoes? Kinda. There are about 150 of them. They're all extinct, and they're not exactly volcanoes. This place is called the Harouge Volcanic Field. But the volcanoes here don't look the way you imagine them. Here you can find different types: small vents, chimneys, and even shield volcanoes. Do you remember what shields look like in historical epic movies about ancient Greece or Sparta? These are round, flat plates with a smooth protrusion. So shield volcanoes look kinda like these inverted shields. They don't turn into a hill or a mountain because the lava coming from these volcanoes is low viscosity, more fluid, and consists mainly of basalt. It spreads further than ordinary lava and takes longer to cool. As a result of such lava eruptions, vast and massive structures appear much wider and lower than ordinary volcanoes. Some of the volcanic rocks here are up to 6 million years old. The most recent eruptions occurred only a few thousand years ago, so it's quite safe to wander around here and take photos. Probably. But why are there so many volcanoes here? Most volcanoes on the planet appear along fault lines crossing the Earth's tectonic plates. Imagine that our planet is like a jigsaw puzzle. Fault lines are the places where the puzzle pieces are attached to each other. When seismic activity occurs, red-hot magma comes out of those cracks, and at that moment, a volcano appears. Okay, so the Harouj volcanic field is a huge fault, right? No. The strange thing is, there's no fault line here. Moreover, it isn't even located next to any of those fault lines. Volcanoes here have a rather unusual origin. For some reason, a huge magma reservoir formed under this area, filled with a surge of molten rock, and there was so much of it that it began to bubble out from different spots. These were not explosive eruptions like those of ordinary volcanoes. Magma here poured out smoothly from numerous vents, turning the ground a dark, coal-black color. All the volcanoes here are extinct, but even if they were to awaken, it wouldn't be a sudden disaster. You'd most likely have time to escape. Okay, now let's move to the Karakum Desert, which is located in Turkmenistan. This desert covers about 70% of the country's territory. It's 135,000 square miles of sun-scorched, barren land. Even if you wander through these hot plains, valleys, and ridges for several days, you still won't leave this desert. But if you go to the north-central part of the desert, especially at night, you can see something fascinating. Already from afar, you will see a bright pillar of light, as if someone started a large-scale fire. You come closer and see a fantastic sight. A huge pit with bright flames. This place is called the Darvaza Crater, and it's not a volcano. The fire has been burning here at night and during the day for weeks, months, even years. This huge pit burns 24/7 and attracts a lot of tourists. Nobody knows for sure how this crater formed, but the most popular story says geologists came here in the early 70s to drill for oil. They got to work, but the ground collapsed beneath them. 3 sinkholes appeared here and they started leaking methane. In small quantities, this gas is safe. It's used as fuel, burning in gas turbines and steam generators to produce electricity. In everyday life, this gas helps to heat houses and prepare food. But in large quantities, methane can cause health problems. It's colorless and odorless, and you may not notice that you're breathing it in. Methane is non-toxic, but it has a suffocating effect, which can lead to serious physical damage. Also, a methane leakage can harm the environment because it's a greenhouse gas. Methane emissions can lead to an increase in global temperatures and the greenhouse effect. So, let's go back to our geologist in Turkmenistan. You know those scenes where a fire hydrant breaks in the middle of the city or a pipe bursts and the streets flood with water? Those geologists had a similar accident with methane. A huge amount of gas began to seep from under the ground, and something had to be done about it. You're in the middle of a desert next to a huge pit where dangerous explosive gas is leaking out non-stop. What would you do? Set it on fire, of course. Scientists thought the fire would soon burn all their gas reserves and everything would be fine. They set it on fire and started waiting. An hour? A day? A week? A month? Years passed, but the gas continued to burn, and it was much better for the environment than invisible seepage. This place began to attract tourists and geologists from all over the world. Many scientists wanted to look at the eternal fire to examine it, and some of them did. In 2013, a Canadian researcher came there and found out that no one really knew how that funnel had formed. Local geologists said that the crater had formed in the 60s, but people began to talk about it only in the 1980s. Now it's impossible to find exact information about the origin of the fire pit because it's classified. Why? Good question. If you have the money and desire to go to Turkmenistan to see the Darvaza crater, don't rush to do it. After lots and lots of years, the crater seems to be calming down. But why? Has all the methane run out? Nope. The authorities just stepped in and tried to stop the leak. In simple words, they found a way to turn off the valve. Now, in satellite images, you can see that the fire is almost out. On the one hand, it's sad that now you won't be able to see it with your own eyes. But on the other hand, the number of fires in this region has decreased threefold. Okay, splashes of fire and magma in the middle of hot dunes don't seem strange. What about active volcanoes in the middle of icy plains and endless snow? On the territory of West Antarctica, scientists have discovered 91 volcanoes hidden under a 2.5-mile thick layer of ice. This makes Antarctica home to the world's largest volcanic ridge. All this ice is putting a lot of pressure on volcanoes and possibly holding them from erupting. But as we know, the temperature is rising all over the world, and the ice is melting. If it loses a lot of mass, it can trigger the volcanoes, which will then melt even more ice. This will lead to higher sea levels and many other problems. But let's talk about this in another video.
Now, if you were to check out the Sahara from space right now, instead of a barren wasteland, you'd spot a surprising sight. Dry land sprinkled with some lakes and rivers in Morocco and Algeria, all thanks to some heavy rains in early September 2024. These aren't oases. This is just the Sahara going back to the factory settings. Believe it or not, eons ago, one of the biggest deserts on Earth was actually a lush paradise full of greenery. Let's first see how the Sahara turned into a desert. During the last ice age, Earth was much colder, and big ice sheets covered a lot of the land. At that time, the Sahara Desert was significantly bigger than it is today, and on our planet there were fewer tropical forests, and the cooler temperatures changed how rain was distributed in the tropics. Now, normally, warm air rises in the tropics, which helps create rain. Since it was colder during the Ice Age, this system got, messed up, and less rain fell in some areas. This caused more dry and desert-like conditions in places that are usually wetter. There was also a lot of dust blowing around in the Sahara Desert, which scientists found in old ocean sediments. But about 12,500 years ago, something surprising happened. The dust levels went way down. This meant that the Sahara got a lot wetter, which is a sign that the climate suddenly warmed up for a while before cooling down again. After 12,500 years ago, the Sahara became a much greener place, like a savanna, because a weather pattern called the Intertropical Convergence Zone, a mouthful indeed, moved north during summer. This wet period was at its best around 4,000 years ago, when temperatures were a bit warmer than today. At that time, more rain fell in the Ethiopian highlands, which made the Nile River carry more sediment. However, there was another big change called a Heinrich event, which caused the Intertropical Convergence Zone to move back south. This led to the Sahara and Arabian regions drying out quickly. Because of this, the Nile River had much less flooding between 2700 and 2100 BCE. Long story short, too late for that. The Sahara has gone through wet and dry cycles due to changes in the climate and weather patterns over thousands of years. Up until recently, we've known about the Sahara in its dry era, but in September 2024, an unusual cyclone rolled through. It hit Morocco, Algeria, Tunisia, and Libya, and filled those dry lakes and rivers. The satellite images from NASA of before and after the rains are stunning. It's like the Sahara has had a makeover. Some areas in North Africa received up to 8 inches of rain. For comparison, Seattle gets about 40 inches per year, only 5 times what the Sahara received. I say only for one simple reason. Seattle has a reputation for being quite rainy, while the Sahara does not. The tricky part is those 8 inches. Essentially, the entire yearly quota for this area fell in a matter of moments. So, in a way, it might have felt rainier in the Sahara than in Seattle. The mountains funnel the water into ephemeral lakes in northern Algeria, which recently expanded to over 70 square miles and reached depths of more than 7 feet. That's enough water to sustain it for a year. So what exactly are these ephemeral lakes? Well, they're basins that fill up for a short time each year, but might stay dry for several years if the rain doesn't cooperate. Sometimes water flows into them from a small surrounding area, or it can just be good old-fashioned rain. Now, a big question arises. How come these lakes exist in the first place? Well, generally they form because there's excess water trapped on the surface. But the soil in the Sahara is incredibly dry. Shouldn't it act like a sponge? It must be thirsting for moisture. Well, think about how eagerly your potted plant drinks up water when you return home from a vacation. However, no matter how parched it is, dry soil can only absorb a limited amount of water, which is often quite small. And just like your potted plant, it doesn't necessarily drink it all. You might simply be overwatering. Or, if you check the saucer below, you could find a mini flood. Another significant factor preventing the soil from absorbing water is the lack of vegetation. Under normal conditions, trees, shrubs, and various plants help retain moisture. In the desert, however, it's nearly impossible. There may be a few palm trees, but that's about it. This also explains the formation of those temporary lakes. Precipitation that isn't held by plants accumulates in low-lying valleys and depressions, creating these fleeting bodies of water. These lakes may only last for a limited time, but that doesn't mean they shouldn't have names. For instance, the beautiful lake adorned with swaying palms that you see is called Lake Yasmina, located in the oasis town of Merzoga. In certain areas of the desert, where the dunes rise, it may appear as though you're looking at a mirage, but it's not. The sand dunes are partially covered by water. Remember how I mentioned 8 inches? Well, that's not entirely accurate for some regions. In fact, there are places where the flooding is so extensive that the palms are submerged up to their crowns. Now, the last time we saw a downpour this intensive was 30 to 50 years ago. But this rain is more than welcome. After 6 consecutive years of drought, Morocco really needed it. Lakes that had been dry for decades, like Lake Ariki, are finally getting some much-needed water. A recent analysis revealed that out of the hundreds of storms that have hit the region since 2000, only 6 brought enough rain to start filling up this lake. And of those, only 2 resulted in a lake level higher than what we saw in September 2024. So while this torrential rain seems like a blessing, the big question is, will it last? The answer is yes. When humid air from near the equator meets the hot, dry air from the north, the Sahara Desert tends to get more rain. Scientists say this collision zone is shifting further north as the planet warms, and it warms, so it's likely to keep moving that way over the next couple of decades. So I seem a bit overly optimistic about this, and the truth is, the news isn't entirely positive. The reality is that no one was truly prepared for a flood situation like this. Moreover, remember that this isn't some Southeast Asian country where people are accustomed to dealing with water. This is the bone-dry Sahara. That said, I think you know what I'm getting at. Tragically, at least 18 people lost their lives to the intense rains in southern Morocco. The authorities are gearing up for even more heavy rain in the region. But if that's the case, could it mean the Sahara is facing extinction? And what would that even mean for us? It might sound a bit strange, but our planet actually relies on deserts, and the Sahara is no different. At first glance, it may seem like a barren wasteland, and it's nothing to write home about. But deserts play a crucial role in our ecosystem. They act as major carbon storage sites and are considered net carbon sinks, with the Sahara alone holding an estimated 1 trillion metric tons of carbon. In the fight against climate change, these existing deserts are like a buffer, helping to keep the temperatures within acceptable levels. Yeah, deserts are scorching hot, but they act as the world's air conditioning. Plus, desert sands are an unexpected source of nutrients for lush areas like tropical rainforests. Believe it or not, scientists have found that the sand particles from the Sahara have a hand in nurturing the Amazon rainforest. These particles travel across the Atlantic Ocean, riding the winds all the way to South America, where they enrich the soil in the Amazon basin. Without the Sahara, experts believe the Amazon rainforest could face serious collapse. "11,000 years ago, give or take, the most famous desert in the world, the Sahara, was all green and alive, with lakes, rivers, grasslands, and forests. Several thousand years later, it all changed. But then, in 1877, a Scottish businessman, Donald Mackenzie, got the ambitious idea to create a sea right in the middle of the Sahara Desert. Mackenzie thought he could dig a channel from a lagoon near Cape Juby in northwestern Africa south to a large island plain. He thought this area was very low, about 200 feet below sea level. If he flooded it with water from the Atlantic Ocean, he believed it would create a giant inland sea, about the size of 60,000 square miles. His idea was to use the new sea for commercial navigation to West Africa, which had plenty of valuable resources and markets with huge profits. Even though Mackenzie had never visited the Sahara himself, he read about other dry desert areas below sea level, like Tunisia and Egypt, which had salt lakes called chats. But the businessman was wrong about how elevated the plain was and didn't receive enough investment, so he didn't bring his project to life. A French geographer named François L. Roder and a diplomat who developed the Suez Canal came up with a similar idea a year later. Roder was inspired by Greek historian and geographer Herodotus, who mentioned the Bay of Triton in his writings. It's sort of an Atlantis of Africa, as there is no proof it really existed, and no one can tell where exactly it was located. The salt plain could have been the seabed of the Bay of Triton, and they could bring this sea back to life. So the French crew thought they could dig a channel from the Mediterranean Sea into a seasonal salt lake in present-day Tunisia. Water would flow into dry basins and create an inland sea. They were hoping it would be around 3,000 square miles in area and 75 feet deep. It would definitely require a huge amount of water. The new sea was supposed to turn the dry desert into a flourishing garden. The climate in the area would become cooler, and there would be more rainfall in the region. And here comes the best part for the French. They'd replace trade caravans with steamships and generate more profit. The cost of this project would be almost $1 billion in today's money. Some people got worried that this new sea would create swamps full of dangerous bacteria. The French authorities stopped the project when they found out that many areas that would be involved were not below sea level, and the plan was just impossible. Now, some people were also afraid it could tilt the Earth on its axis in a dangerous way, or cool down Europe to the point there would be a new ice age. But the idea lived on, and most recently, Egypt was considering flooding the Qattara Depression in eastern Sahara through a canal or tunnels from the Mediterranean Sea. Water would evaporate quickly because of the desert climate, and a controlled balance of inflow and evaporation would let them generate huge amounts of hydroelectric power. But the project involved using atomic power to carve the new channel, and it didn't come to be. Famous writer Jules Verne described the flooding of the Sahara in his final novel, Invasion of the Sea. In the book, the scientists didn't proceed with their plans to turn the desert into a sea, but an earthquake did the job for them. So if the book comes to life, we might go swimming at a new Sahara sea resort in the future. Another massive flooding project has to do with Lake Erie in Australia. When it fills up completely, it becomes the largest lake on the continent. It happens only a few times a century, and when it does, the lake has the same salinity as seawater. When it dries up, it becomes extra salty. There was an idea to flood Lake Erie with seawater using a big canal or pipeline. It was supposed to make more water evaporate, and it could bring more rain to nearby areas. But when scientists did their math, they saw that the extra rainfall would be very small. It is so tricky because Lake Erie is below sea level, and the area gets really hot, so lots of water evaporates every year. This means salt would build up very quickly, and the canal could get blocked by all the salt. If a big canal sent water to the lake, it could create a small sea, but without removing the salty water, the lake would collect tons of salt every year. In 1930, several British scientists suggested freeing 100,000 square miles of the North Sea from water. Huge dams were supposed to stop the water, and rivers flowing into that sea would be diverted somewhere else through canals. There would be a railroad connecting London to Berlin and a bridge across the English Channel. Antwerp and London would keep their access to the sea, and Rotterdam would lose its busy port. This idea never became a reality, but quite recently, one Dutch and one German scientist came up with a similar project. Their idea is to build a dam that would be 295 miles long between North Scotland and West Norway, and another section between West France and southwest England. The scientists did some math and figured out that the project would cost somewhere between $276 and $552 billion. Sounds like a lot of money, but it could save around 25 million people living in 14 European countries from high water. So, if we spread that budget over 20 years, the cost would be 0.1% of their combined GDP. And although it looks like science fiction, we already have the technology to build something like that. The depth of the North Sea between France and England is hardly over 328 feet and is around 416 feet between Scotland and Norway. We can already build fixed platforms in depth over 1,600 feet, so it should be fine. This project would turn most of the North Sea into a huge freshwater lake with no tides, and it would mean huge changes in its ecosystem. Plus, it would become more expensive to ship goods across this sea. The fishing industry would lose huge amounts of money, and it would also cost a lot to build huge pumps to transfer all of the river water that currently flows into the North Sea to the other side of the dam. So, the best that scientists can do is monitor the situation and hope there won't be a need for such a dam. Meanwhile, a German architect and engineer came up with another huge dam idea in the 1930s. It was supposed to completely change the inside of Africa with giant inland seas. The plan was to build a huge dam on the Congo River where it flows through some deep, narrow valleys after joining with the Kwa River. This would create a massive lake that would be bigger than the states of California, Nevada, and Oregon combined. Once this giant lake filled up, it would overflow into another river, which would then pour into the Sherry River, one of the rivers that feeds Lake Chad. Lake Chad would grow much larger, just like it was believed to be 10,000 years ago. The water would flow from the lake through Algeria and Tunisia right into the Mediterranean Sea. This new river would be big enough for ships to travel. It could replace trains or planes and would make it much easier to move goods and people across Africa. Back then, people didn't think much about how this could hurt nature and focused on how it would help the economy. So, the Sahara Desert is so big that it covers 8% of the world's territory. It's bigger than the USA or China. Surprisingly, the Sahara is not the largest desert in the world. It is the third largest, behind Antarctica and the Arctic. But it is definitely the hottest one. Temperatures there reach 136 degrees Fahrenheit. This place has some of the most incredible sand dunes you've ever seen, towering up to 1,476 feet. But here's the kicker. There's a real risk that these dunes might continue to spread until they cover the entire world. Surprisingly, the influence of the Sahara Desert extends far beyond its borders. Its dust, carried by powerful winds, makes its way to the UK and across the European continent, particularly in winter. This dust, settling on the ground where it rains, is a familiar sight to those in the UK, often leaving a red residue on cars. This connection between the Sahara, England, and Europe serves as a stark reminder of the global reach of environmental phenomena. You might think this is not a big deal, but it could turn Europe into a desert, leaving its soil infertile and Europeans with no food. Soil is a fundamental aspect of human existence, just as crucial as clean water and air. Without it, we're left with nothing but a bleak and barren landscape. The Sahara Desert has already made its jump across the Mediterranean Sea, which is concerning and could change the landscape forever. 1/5 of Spain has already turned into a desert. The next victim is Italy, which also faces the problem of desertification. In fact, almost all European countries have the same issue. According to an expert, the land that has not changed for nearly 2,000 years will become mostly rock, and people living on this land will be gone. 60% of the soil in Moldova is gone, and the problem has expanded beyond the Black Sea. It has reached China and Mongolia, thousands of miles away from the Sahara Desert. All of this causes losses of $4 billion a year. The threat is so significant that even the UN has gathered the necessary resources to solve the problem as soon as possible. Italy is sending help to Africa to stop the Sahara Desert from expanding. If this process does not stop in the next 10 years, millions will be forced to leave their homes. The Sahara Desert is growing for approximately 30 miles per decade. You do the math and see how long it will take to cover Europe. Since 1920, the Sahara has expanded by around 10%. But not all hope is lost because more than 172 countries have joined to put a stop to the desertification of the world. The World Food Program is a project that aims to help bring back green land that was once present in the Sahara. When they told people who called the Sahara home what they were about to do, the latter basically laughed in their faces and said it was impossible. But when you have a specific goal in mind, the impossible becomes possible. If we traveled back around 5,000 years into the past, we would see a beautiful forest with lush green trees and grass. Africa's climate has been changing for 21,000 years, from fantastic greenery to uninhabitable deserts. This has to do with Earth's rotation and the monsoons that bring water to this dry continent. But with the help of scientists and some clever tricks, we can bring the greenery back and stop the Sahara in its tracks. The Senegal River serves as a border between the Sahara Desert, Senegal City, and Mauritania. When you look at this area from space, you'll see how the desert is expanding to Senegal because the vegetation along the riverbank is almost non-existent. Forests can serve as a barrier, stopping the sand from getting blown away and the desert from expanding. An effort to create a great green wall is being made, and how they do it is actually quite impressive. Nothing has been growing in the currently restored area for more than 40 years, making locals find other places to call home. People were thrilled when they saw that the land could be restored. They're very committed and learn to work with the soil and grow food. At the same moment, more than 30,000 hectares have been restored and transformed into lush greenery. The Sahel region is the starting point of desertification, and it is crucial to establish a green wall in that area first. To make this wall is not rocket science, since it only takes a few simple steps. The ground there is baked by the sun and as hard as a block of concrete. If you've ever poured water on concrete, you know that it just flows away. It doesn't stay in one place. So they had to create water-retaining half-moons that would hold the water and make it available to plants. When you learn about how these half-moons work, you might say, how did they not think of that sooner? Actually, this technique is ancient, and it was once implemented in Sahel, but it was lost over time. When the rain falls, the water is collected into the half-moons that are positioned a bit lower than the ground below contour lines. There is also a kind of bank at the end of the shape that prevents water from overflowing. And in the middle, there are plants that are happy because they have plenty of water to thrive. Also, it's essential to grow native plants that are kind of used to harsh conditions, like sorghum and millet. These plants have been surviving there for thousands of years and produce a good amount of biomass, which means the land can be rehabilitated faster and people will have food sooner. The water that will enter the half-moons won't be lost. It will penetrate the ground and top off underground waters. This will ensure the ground that H2O will never run out and that future generations will have usable aqua. This brilliant planting technique is not limited to half-moons. People also create lines and plant various vegetables, such as tomatoes. Next, there are places only for trees, like lemons or oranges. After a long hot day, nothing is better than a freshly made cold lemonade. The trees will also protect the soil, and with some luck, there will be a new forest in the Sahara Desert. The goal is to copy the forest dynamic. Start with small plants and gradually expand to bigger plants that are more useful than the tiny ones. They are aiming to plant more than 10,000 trees. Right now, many people are leaving the Sahara after the rainy season, going to cities or leaving Africa altogether. At this time of year, villages are like ghost towns. Only animals can be found there. Most people are gone. I mean, who would blame them? Nobody wants to live in the sand where nothing grows. Luckily, with all this new, old technology being developed, Many people are slowly but surely returning to their land and starting to work in agriculture. The best thing is that there are no brutal winters, so plants grow 12 months a year, and people can always have food. People are becoming more social because now everybody stays in their villages and doesn't travel much. If this project works out, Africa will be saved, and the world won't turn into a giant desert.
Africa is ripping itself apart. A giant crack is tearing through the continent and stretching south like a zipper being pulled open. And it's happening faster than anyone expected. Now, scientists think the main trigger might not be buried deep inside Earth, but up in the sky. That's right. What might be speeding up this breakup process is the region's drying climate and brutal droughts. And that feels off, right? Usually tectonic plates move first and the climate changes afterward, but in East Africa, it might be flipped. The climate may actually be helping the plates pull apart faster. But first, let's look at what's really going on there. So, Earth's crust isn't one solid shell. It's made of giant tectonic plates, massive slabs of rock that never stop moving. They grind past each other, collide, slide under, climb over, or stretch apart. This motion is so slow, we don't notice it, but over long periods, those tiny shifts reshape continents, just like what's happening in Africa. For about 30 million years, the Arabian Plate has been moving away from the African Plate. That slow pull split the land. The seawater rushed in to fill the gap, forming the Red Sea and the Gulf of Aden. And that's not the only breakup happening there. In Eastern Africa, the Somali Plate is stretching away from the Nubian Plate. This is opening up the East African Rift Valley, cutting right through places like Ethiopia and Kenya. The region where these plates meet has a name. It's a triple junction. But in this case, they aren't crashing into each other. All three tectonic plates are diverging. When that happens, the crust gets pulled in different directions at once, like fabric being stretched from three corners. It weakens, thins out, and cracks open. They're pulling apart at different speeds too. The Arabian Plate is moving away from Africa at about an inch per year. The two African plates are separating more slowly, roughly between half an inch and 0.2 inches per year. And as they open that gap, hot material from deep inside Earth rises up and hardens, creating brand new seafloor along the split. I know, a few inches per year sounds ridiculously slow, but what makes this event so fascinating is that we're watching it happen in real time. We can actually see Africa slowly breaking apart, and it's terrifying. Back in 2005, a 35-mile long rift that opened up in the Ethiopian desert. The crack is 20 feet wide in some places, which is roughly the size of a shipping container. This is just one example of how active the region really is. From space, satellite images show valleys and rifts slowly widening over time. And down on the ground, people are posting videos of places where the Earth has already split open, leaving big cracks and gaps. Roads, houses, even schools are getting torn apart. The whole area keeps shaking from earthquakes, and the volcanoes are very active. What I mean is, even though this splitting process is super slow, we can actually see it happening, and it's unstoppable. Experts believe this crack in the East African Rift Valley will become a gateway. Waters of the Indian Ocean will eventually invade the valley and fill the growing gap. That will help pull the land apart even more, and eventually it'll create a brand new ocean. And we know that can happen because Earth has done it before. That's exactly how the Atlantic Ocean formed about 180 million years ago, when South America and Africa pulled away from each other. If the East African Rift keeps opening up, parts of Eastern Africa, Somalia, Kenya, Tanzania, Mozambique, and a big chunk of Ethiopia could one day break away from the rest of the continent. That means countries like Zambia and Uganda could actually end up with brand new stunning coastlines. But don't pack your swimsuit yet. Unfortunately, none of us will be swimming in the waters of this future sixth ocean anytime soon. Scientists estimate the full split would take about 5 to 10 million years. That's basically forever in human terms. But in Earth terms, it's surprisingly fast, almost like record speed. Now, scientists are trying to figure out why it's happening so fast. I mean, faster than it should. And here's a new intriguing possibility: a drying climate. One of the biggest clues starts right here at Lake Turkana. This lake in Kenya is about 19 miles wide, and it's up to 400 feet deep in some places. But that's nothing compared to more than 5,000 years ago, when the lake level was up to 500 feet higher. Back then, the continent was going through something known as the African humid period. It was a time when Africa was wetter than it is today, and the Sahara wasn't a desert at all. It was green, wet, and full of lakes, rivers, and vegetation. But since then, the whole region has shifted into a much drier phase. So researchers took sediment samples from the bottom of Lake Turkana to figure out past water levels and how sediment washed into the lake over time. And while they were doing that, they noticed something else. Those sediment layers preserved lots of tiny faults and even the fingerprints of ancient earthquakes. Wait, wow! That means Lake Turkana might not be a simple lake. It could actually be one huge crack in the earth that eventually filled up with water. In other words, it could be a direct result of this whole rifting process. And now scientists think the same thing might be true for other deep, narrow lakes in the region, like Lake Malawi along the Tanzania-Mozambique border. So, scientists came up with a wild theory. What if these lakes are helping split Africa apart faster? Okay, maybe the theory isn't that wild. After all, water can indeed affect tectonic plates. For example, when glaciers melt and disappear, all that weight is removed, and the land underneath slowly pops back up, kind of like bread rising after you take something heavy off of it. That's called isostatic rebound, and big amounts of water can do the opposite. They press down on the crust, which can also affect things like faults and earthquakes. At Lake Turkana, something interesting shows up in the data. After the African humid period ended, the faults around the lake started moving faster, by about 0.007 inches per year. I know, that's a lot of zeros. But over thousands of years, that extra push can add up. And it could help explain why earthquakes might be more common in the region today than they were around 8,000 years ago. The study then ran computer simulations and found two likely reasons the shaking and fault movement sped up. First, there's less water pushing down on the ground. With that weight gone, the faults can slide more easily, like loosening a vise that was squeezing two pieces of wood together. Second, there's a volcano on an island on the south side of Lake Turkana. Deep underground, it has a pocket of hot, molten rock. When the lake level dropped after the African humid period, the pressure on the earth below eased up, like taking the lid off a pot. That lets the rock underneath melt a bit more. The extra melt flows into the volcano's magma chamber, swelling it up like a balloon. And that extra pressure can jolt nearby faults and trigger more movement. So yeah, drought and falling lake levels could be speeding up the splitting process. But it's not like the climate is creating the rift from scratch. It's more like the ground is already under tension, and the climate is giving it a little extra push. The real reason Africa is breaking apart might be related to something called superplume, an enormous column of scorching hot rock rising from deep inside the earth. Think of it like a balloon underground that's slowly filling up. As it pushes upward, it puts pressure on the crust above it. Over time, that pressure weakens the crust and slowly cracks it apart. And even though none of us will be alive to see the final result of this process, it's still amazing to realize that we're watching a continent split, almost in real time.